Good morning, everyone, and welcome to another webinar in the PathOS training series. I'm very glad to welcome you here today for this session. In this session, we will be focusing on important and timely topic on exploring the academic impact of open science. We are joined here by two incredible experts, Thomas Klebel and Petros Stavropoulos, who will share their insights on research and how open science can have a positive impact on academic spheres. Let me quickly introduce this project for you before we begin. Thomas, switch the slides. Thank you. PathOS is a Horizon Europe project aiming to collect a concrete evidence of open science effects. It studied the pathways of open science practices from input to output, outcomes and impact, including the consideration of enabling factors and key barriers. PathOS brings an interdisciplinary team of open science experts together, as you can see on the slide. There are also infrastructure developers, bibliometrics, scientometrics, data scientists, sociologists, and policy experts. Please, next slide. And here on this slide, you can already see some of the key outputs. PathOS aspire to serve as a gateway to a wide range of resources that shed light on the impact of open science. I invite you to browse the PathOS Open Science Resource Hub, where you can find all different kinds of PathOS results. For example, you can find their Open Science Impact Indicator Handbook, which includes indicators, recipes, and tools that will help to measure open science impacts. You can also browse through the examples of open science impact through our Zotero library, or you can also search through Open Science Stories Registry, where we share real examples from open science stories and their outcomes. Today, please, next slide. Today, I'm very glad that I can welcome here our speakers, Thomas Klebel. Thomas is a member of the Open and Responsible Research Group and a senior Research at Known Center. In his research, he investigates unintended consequences of current implementation of open research, also the ways of improving the reproducibility of research findings and avenues for sustainable business models around open research infrastructure. Thomas is also interested in causal modeling and ways of improving research practices. Thomas completed his study in sociology in 2024 and holds a degree in music performance. In PathOS, Thomas is leading the scoping review on academic impact that you will hear today about. Our second speaker is Petros Stavropoulos. He holds a bachelor degree in military science and technology, also another bachelor degree in informatics and master degree in computer sciences. Petros has been currently pursuing a PhD in computer science. Since 2019, he has been working as a research assistant at the Athena Research and Innovation Centers. Petros contributing to several national and European projects, including, for example, Tier 2 or SILIC, and also PathOS. And in PathOS, Petros is co-leading the work on case studies, and today he will share with you details about one of these case studies. We are excited to have you both here to share your insight with us, and without further ado, I would like to pass the floor to Thomas to begin his presentation.
Thanks, Teresa, for the introduction. Yes, and you also mentioned one of the key aspects I'll be talking about today. We conducted a large literature review on the academic impact of open science, which I'll dive into over the next 15 minutes. And to start us off for this, I'll briefly explain the two concepts, academic impact and open science, and how they are related in our view here. I'd assume that most of you will be familiar with open science, broadly speaking. And so I'll just briefly frame it here with the definitions from the UNESCO recommendations on open science. And from that, we can see that open science is both a set of practices, but also involves certain principles, underlying principles. And in terms of the practices, we have the well-known practices around open scientific knowledge, such as open access publishing or opening up research data, sharing source code and research software. We also have aspects of open science infrastructures, we have the important aspect of open engagement with societal actors, so broadly speaking, citizen science, and also an aspect of an open dialogue with other knowledge systems. And underlying all of these various practices are certain values, and from these certain principles. And the values are quite important, I'd say. So the underlying values for open science are quality and integrity, also equity and fairness, diversity and inclusiveness, and collective benefit. And the key question is, of course, to which extent the way open science is being implemented right now delivers on these core values and principles, to which extent the hopes that have been attached to open science. So for example, with the open access movement, there was this hope of uniting this hopeful language, at least in the Budapest Open Access Declaration, this hopeful language of uniting humanity in a common quest for knowledge. And the question is to which extent we are actually realizing that. And so the second pillar that we're interested in is academic impact. And the question here is, of course, how that can be measured. One approach that we took in the PathOS project was to devise certain indicators that we can use to measure various aspects of academic impact in a quantitative way. And we have this indicator handbook that explains some of the concepts, but of course that doesn't cover all of the concepts that could be relevant. And so in our scoping review of the literature, we looked at various key aspects that we investigated and then also sourced from the literature we were actually looking at. And the aspects that we looked at were citations. So this is a very common type of academic impact, or at least commonly associated with academic impact. We also looked at quality, efficiency, and productivity. So grouping some of the terms together, equity, diversity, and inclusion. And also a further range of aspects around reuse, reproducibility, novelty, ethics and integrity, and trust. And the way to link them together is via this impact pathway framework, where in a sense we start with an activity on the left side of the diagram. Here in this example from one of our, it's a draft from our deliverables. We start with citizen science intervention, citizen science activities where citizens are involved in the research process to a certain degree. And this then leads to a higher number of people actually participating in science and participating in these activities and in general collaboration with society. And these very immediate outputs then translate into certain outcomes on the shorter term, such as empowerment on the side of the citizens or education and awareness, but it might also have effects on the efficiency or quality or novelty of the scientific findings themselves. And this then in turn leads further down to short-term impacts and long-term impacts. And one of the key issues to acknowledge here is, of course, that this, let's say, pipeline from activity to outputs, outcomes, and then finally towards impacts can be a relatively complex pathway and can also be relatively difficult to track empirically, because some of the long-term impacts are hard to measure on a timescale for a typical study. And so what I'll be presenting with the results of our scoping review is to a large extent also focused on the more immediate sets of outcomes, but then sometimes linked via logical argument towards longer impact statements. And to get right to it, the question is, how does open science create academic impact? In which areas can we find evidence that it does? We conducted a large scoping review to address this main research question: what evidence exists in the literature regarding the effect of open science on the academic impact of research? So for this, we started with a keyword search that unearthed more than 10,000 articles, and we iteratively went through them and narrowed down on this set of 485 included studies that in some way report on a demonstrable academic impact of open science. And we also had a couple of secondary research questions. So we wanted to see whether the impacts are positive or negative, what kinds of mechanisms produce those impacts, also whether there are certain drivers and barriers, certain moderators that change how a certain impact comes about. And finally, and relatively importantly as well, whether there are any specific knowledge gaps in the current research on the impact of open science on academia. In terms of the different open science practices, in the literature that we found, there was a very large portion of articles reporting on the impact of open access. This was clearly the largest group. The second largest were studies focused on citizen science, and then we also had a good chunk of studies looking into the effects of open or fair data. The other areas, such as open evaluation, things like open peer review, or open methods and open code, were more scarce in the literature. And if we look at the other end, which types of impact did these studies report on? Somewhat mirroring the first image, the most frequent aspect that they report on were on citations, and this is relatively obvious. There's this large literature and debate around the so-called open access citation advantage, and this is kind of visible from this figure that we have many studies looking at open access, and then as the outcome, whether open access leads to more or fewer citations. We also had many studies looking into outcomes of quality as a result of open science interventions, also into efficiency and productivity, and then a certain further range of aspects. And one of the important aspects to point out here maybe is that we were interested in how open science changes something. So not whether studies that are open access do have some impact, but whether by virtue of being open access, there is a change there. So we want to look at to which extent the open science aspect has an effect on the impact. Does it change it? And not just whether there is any impact there. In terms of disciplines, broadly speaking, the studies covered a good range of studies, but there were certain we have certain clusters here. What we can see here is that we looked at each individual study and discerned which topic it studied. So with this example of the open access citation advantage, there might be a study that looks into the citation advantage of open access articles in a certain field of medicine or in the natural sciences, or just very broadly. So we have a share of studies here, as you can see in gray, that looked at either just a very general approach, or they looked at multiple fields at once, or they didn't really specify which fields they looked at. The largest share came from the natural sciences. So on the right, you can see biological sciences, earth and related, environmental sciences, and a couple of others. And then also a large share from medical and health sciences that looked into these impacts. And in terms of the timeline, this is a relatively typical graph for the growth of the literature. We can see that, so we started in 2000, and evidence there was relatively low, but then it started to pick up, and the drop-off at the end is just an artifact of searching in a database and having to stop at a certain point. And now finally, I'll go through some of the main findings from our study. Sort of the largest aspect, as we've seen, was on citations, where we found a small to moderate increase from open access, also from open and fair data and open evaluation on the respective articles. And as you can find, if you read the paper, there's a lot of debate and different aspects about these open access citation advantages and open data citation advantage. Especially for the former, there are certain biases that are well known, but many studies don't take them into account. So it's not very easy to have a very clear picture. And even after looking at those about 200 studies, we can only say that it's small to moderate increases, but many studies don't have appropriate designs to really substantiate some of the claims they make. In terms of citations, we also have unclear effects from open code and no effect from open science badges. In terms of quality, we found studies to report neutral to moderately positive effects from open peer review and conflicting evidence from open access. Citizen science had a neutral effect on the quality given sufficient training. So this is a key sticking point in the literature on citizen science, that one of the key questions was whether data gathered by citizens is of sufficient quality to conduct scientific studies. And the consensus that emerged seems to be that yes, it's of sufficient quality, and there can be some debate about what that sufficient means. So that's also somewhat relative. But one of the important aspects is that citizen science is just like any other methodology. It needs a proper place. It needs to be considered whether it's the right method for the specific research question. And then it needs appropriate procedures. And so if sufficient training is provided, then the quality is also up to the standard that's necessary. In terms of efficiency and productivity, we see a clear positive effect from citizen science because if you get a bunch of volunteers to help in your study, that's obviously more productive than if you try to do on your own, but also in terms of knowledge transfer through open access and open science in general. An unclear effect of open evaluation and some wasted time from engaging with predatory publisher emails. In terms of equity, we found that open access tends to lead to more diverse citations and also to more international collaboration. But there are certain negative effects of open science, particularly around the APC-based open access model, and also in terms of open and fair data, that researchers with fewer resources are marginalized to a certain extent. And also citizen science activities are focused in the global north, so this methodology is not benefiting everyone equally. In terms of reuse, there's a clear positive effect. If open and fair data is available, then it's possible for people to reuse it. But for reproducibility itself, it's not so clear. There are no specific positive or negative effects of open and fair data or open methods on reproducibility, but certain positive effects of pre-registrations and registers reports on general aspects of reproducibility. In terms of novelty, we have potentially positive effects of open science practices on the rate of true discoveries. In terms of ethics, there are certain unclear effects and some potentially negative effects of opening up data. And in terms of trust, we found studies reporting a positive effect of open science badges on the trust in results by scientists, but not by the general public, interestingly enough. But that would be societal impact, and that was the topic of another webinar. So overall, just briefly summarizing, we can see that in general, the colors are more green than red, let's say, but we need to account for both. So open science tends to have a positive impact, but there are certain areas where it can have a negative impact, and we should be mindful of those. And with that, I'll hand over to Petros.
Thank you, Thomas. Let me share my screen. I hope that you can see it. Perfect. So, hello, I would like also to welcome and thank you for joining this training webinar. In my presentation, I will be presenting preliminary findings from our case studies within the PathOS project, specifically the one regarding emerging topics in AI and climate change research. In general, in PathOS, in our case studies, we try to explore how open science practices shape academic impact across different domains. So we analyze a variety of open science aspects, from open access policies and open data repositories to public funded research resources and emergency knowledge sharing during, for example, the COVID-19 pandemic. By examining all these key academic impact indicators like citation impact, dataset reuse, interdisciplinarity, collaboration intensity, and so on, we can assess how open science fosters greater research visibility and engagement. Using methodologies such as A/B group testing analysis, field of science classification, citants and citations analysis, we gain insights into how these practices actually contribute to knowledge dissemination and innovation. Our findings highlight that open science is not just about access, it's about accelerating academic influence, fostering collaboration, and shaping the future research and policy making. In this presentation, I will dive deeper into one of these case studies, the emerging topics case study, where we'll be examining open access in AI and climate research and its broader impact. So, as I mentioned, in this case study, we'll be addressing the evolving recent landscape where global challenges like AI and climate change are rapidly advancing. So open science plays actually a critical role by making research more inclusive and interdisciplinary, fostering collaboration and enhancing accessibility. The key research question of this case study that we try to explore is how does open access impact the development and persistence of new research topics, specifically in AI applications for climate change. To investigate this, we compare various groups. We compare open access publications versus closed access publications, Horizon 2020 funded versus non-funded research, and different types of open access colors such as green, gold, bronze, and so on. So for reference, green open access is when authors self-archive their work for free public access in a repository, such as arXiv, and other open access colors or models, such as gold, hybrid, and bronze. In those, actually, publishers provide the access, often with costs or restrictions. Through these comparisons, we want to isolate the effect of open access on research visibility, collaboration, and citations to demonstrate the role of open access in the growth of AI in climate change research. So, to conduct this study, we actually collected publications related to AI and climate change from the OpenAI Research Graph and Semantic Scholar. And in the table below, you can see that most of the publications were closed access. And from the ones that were open access, only a small subset was actually funded by Horizon 2020. On the graph on the right, you can see how the trend of the publications by access type, which highlights actually a significant increase in open access publication in recent years. And as Thomas said in his previous presentation, the cutoff is due to the data collection process in 2023. Our approach for this case study actually follows a comparative analysis across different open access types and funding models. So we compare green-only publications versus a mix of open access models, specifically gold, hybrid, and diamond, which from this point on, I will refer to as open access publication in this presentation. So we have green-only open access and open access. Also, we want to control for some confounding factors, specifically gender mandates, for example, the Horizon gender mandate, research quality, such as the excellence of the participants in Horizon 2020 publications, as well as science industry collaboration, for example, partnerships within industry, within the Horizon. So the diagram on the right actually illustrates how we integrated our data sources along with all the tools that we used to track citations, to track patents, collaborations within the industry, and classify research publications, linking them to sustainability goals, scientific fields, and emerging topics. Now, if we want, looking at some of our preliminary results, let's focus on the academic impact indicators within Horizon 2020 funded publication. So in this case, we want to focus on citation impact through 3 metrics. The first metric is field-weighted citation impact, or FWCI score, which actually measures how often a publication is cited compared to the global average for similar publications in the same field over a 3-year window. The next one is citation count, so the total number of citations that publication has gotten. And finally is the influential citation count, which actually highlights citations that have significantly influenced the content of the citing paper. So, as you see in this table, our findings show that open access papers tend to receive more citations and more influential citations than green-only open access papers. However, their field-weighted citation impact score is slightly lower, as we see, which suggests that while open access publications gain visibility and engagement from the community, their field relative impact is somewhat lower. If we take a look at societal impact indicators, we take a look specifically on sustainable development goals and gender equality metrics. So for SDGs, for the SDG analysis, we actually found out that most of open access publications focus on SDGs 7, 11, and 3, which are actually related to areas like clean energy, sustainability, and good health, which are often connected to climate change. So that makes sense. This finding makes sense for our case study. And for gender equality, we focus on women participation. So this is the percentage of the papers with at least one woman as an author, and women as first authors, so which papers has the leading author as a woman. Our results on this is that open access publications tend to have slightly lower overall female participation, as we see in the graph on the left. However, there is a higher representation of women as first authors within the open access publications. In terms of economic impact indicators, we assessed two metrics. Affiliation analysis, which actually shows the percentage of publications that are affiliated with both academia and industry, indicating direct collaboration between them, and citation from patents, which actually measures the percentage of publications cited by patents that suggests real-world applicability and industry uptake. Our results here show that open access publications are more frequently cited by patents and have higher rates of academic industry collaboration, reinforcing their value for real-world applications. Now let's take a look at the basis of our case study, which is the emerging topics. So in this table, we have highlighted the top 20 scientific topics that we identified in our collections that includes areas like machine translation, gender bias in NLP, text generation, and more. We observe that most of these topics are within the AI field, and the representation from open access publication is evidently stronger. The thing is that beyond identifying these emerging topics, we also want to analyze and find out how persistent these topics are over time. So persistent topics are those that continue to attract research interest across multiple years. And in our analysis, we found out that open access publication actually has more persistent emerging topics. For example, fields like machine translation, gender bias in NLP, knowledge graphic representation appear consistently in open access literature, reinforcing the role of open access in sustainable impacts for research. Lastly, what we wanted to focus on is we wanted to create a mapping of the AI-related research topics within climate change research and climate change topics found in our collection. This allows us to see where AI is being applied within climate research. Also, in these tables, we highlighted the persistent emerging topics that we identified earlier, showing their relevance in both AI and climate change research. For example, we see through this analysis that argument mining is applied in biofuels and biodegradable waste management, which likely assists in policy analysis and decision-making processes related to environmental sustainability. We see that grammatical error correction plays a role in climate change policy and ethanol fuel research, which actually is used to improve policy documents, reports, and regulatory text processing. We see algorithm optimization techniques that are used in both climate change policies and heat transfer systems that suggest applications in improving computational efficiency for energy-related research. We see fuzzy clustering algorithms that appears in renewable energy commercialization, heat transfer systems, and structural geology that indicates relevance in categorizing and analyzing energy and geological dataset. We see topics like object pose estimation in petroleum production and fossil fuels that may support, for example, automated inspection and fault detection in industrial settings. And we see also, for example, diabetes risk stratification topic in petroleum and fossil fuel research, which could actually relate, for example, in occupational health impacts and exploring long-term health risks for workers in the industry. So in essence, and there are many more examples like this, but in essence, this mapping helps us better understand how AI contributes to these climate change research topics and how open access supports the development of these interdisciplinary connections. So this was the emerging topics case study. I think we go back to you, Thomas.
Thanks, Petros, and you can forward to the next slide.
Yes.
Yes. So I'll close out kind of the things that I talked about from our scoping review with a couple of thoughts about policy implications and future directions that we could take based on our research. So the first aspect, what we observed, apologies. When conducting our review was that, and that was apparent while reviewing our papers, that there is a lot of research about uptake of open science. So many papers demonstrating that somebody is using a certain open infrastructure or someone is depositing data and other aspects of what we would term as people are engaging with open science practices. And then there is far fewer research on actual impacts. And that is at least what we were interested in and what we think is important to also consider the actual impacts and try to measure the actual impacts of the open science practices, because what we find in the literature is that there is a lot of assumed impact. So we say people are using this or that resource, and then because they're using it, we can make a logical argument that this benefits everyone in various ways. But it's also important to actually try at least to measure that, because in some areas maybe the impact doesn't translate as neatly as the logical argument might make it seem. And so we think there needs to be more research in that area and in that kind of from that perspective. The second aspect that we found in terms of the literature is that there seems to be what we could call a streetlight effect. So that people are searching under the streetlight at night in the street, but not where the actual thing they're searching for is, but just where the light is. So the example would be the open access citation advantage. There are so many studies on this subject, to a certain extent also because it's relatively straightforward to measure. It's much harder to do it well, but it's relatively easy to pull up some open access and closed access sources and then compare. And there are many other areas where more knowledge gaps remain and where more research should be focused. Then linking back to what I showed before in terms of this pipeline from activities to outputs and impacts on the long-term end, it's relatively clear also from looking at the studies that we investigated that it's quite difficult to directly measure this relationship between a certain intervention and the long-term impacts, and that it's hard to disentangle it from a very complex web of factors that are influencing each other. So we always have to also, when we try to make these claims, be clear about our assumptions and the limitations of those claims. We also observed the lack of standards on defining and measuring open science impact, and this was relatively apparent also in the citizen science example, where, as I said before, many studies concluded that the data that they collected was sufficient for their purposes, but of course that can be changed depending on what the results are. So there's also a need for better standards, also in the area of open access citation advantage, for example, better standards of measuring specific impacts and better methods in that area. In line with the first point, also, we think that it's important to have more support for studies looking at the impacts of our interventions more broadly. There are a lot of interventions and a lot of open science activities, and we believe that it's important to measure as best as we can what actual impact those interventions have. And a broader point, just looking at the picture from before, we had more positive impacts than negative impacts, but still also the incentives for some researchers to engage with open science practices, engage with citizens, or to open up their research processes are somewhat lacking in many areas, in many countries. Countries differ to that extent. And so I would also argue that we need to play a stronger emphasis on more diverse types of research outputs in line with the current reform movement on reforming research assessment, which we believe is very important. Back to you, Petros.
Thank you, Thomas. So from our case studies and the emerging case study, what we actually found out is that open access supports sustained engagement with emerging topics like AI and climate change, increasing accessibility and collaboration, which is evident through our persistent emerging topics analysis that I showed in my previous slides, where open access publications actually consistently supported long-term research on high-impact topics. Secondly, what we found out is that impact varies across different open access types, such as green, gold, diamond, and so on, which suggests that the need for policy prioritizing models that enhance research visibility and citation. So this variation was highlighted actually in our academic impact indicators, where citation counts and influential citations were generally higher for open access, but versus green-only open access, but the FWCI score was slightly lower. That reflects actually differences in relative field impact. So by considering all these insights, policies can be better tailored to maximize the long-term benefits of open access in driving both academic and societal and economic impacts. Back to you, Teresa.
Thank you very much, Petros and Thomas. It was very rich presentation. And now I would like to open the Q&A session. So I wonder if any one of you has any questions. So please prepare them. You can write them in chat, or you can unmute yourself and ask directly. And before you will prepare your question, so I have a first question for Thomas. Thomas, how do you see the relationship between open science practices such as open access and fair data and academic impact in areas like quality, novelty, and interdisciplinarity, considering the challenges in measuring these factors?
Thank you, Teresa. So this points back to what I said before to a certain extent. that it's and you allude to it as well in how you pose the question, in that there are challenges in measuring these aspects. And so for logical reasons, it would be very straightforward to assume that fair data has an impact on the quality, because people spend more time documenting their data sets, or making sure that the data that they share is actually of high quality, and that this in turn might lead to more novelty or more interdisciplinary approaches, because people pick up the open data and then engage with it. But in the study that we did and in the literature that we reviewed, we didn't find any specific evidence for that. That doesn't mean that this kind of evidence isn't there, but it's just that maybe it wasn't researched yet, or not researched enough in a way that we would pick it up in this broad review. And the second aspect in terms of open access, there is actually a link which I mentioned to article quality. That's also that has one relatively obvious aspect in terms of that open access has brought about this phenomenon of predatory publishing. And by definition, quality of articles will be lower in such journals, because there is less oversight and maybe no review at all and no editorial engagement. But the flip side of it is that there is also not much practical impact of this lower quality, because these articles tend not to receive any substantial citations.
Perfect. Thank you for the answer. There is actually a follow-up question on this topic, and that's a question: how do you measure quality of research, or what are the measures used to report the quality of research?
That differs. So in citizen science, that's a relatively clear case. Let's say people generally looked at certain expert collected data sets, and then volunteer collected data sets, and then try to put them next to each other. But one important aspect there that people then sometimes forgot, and only a few studies highlighted, is that also experts data can have errors, for example. So it's important to make sure that the comparisons are fair, and that assessing the quality here is correct. On a broader point, as I kind of presented, we have many studies, and they had different ways of looking at quality. So I don't recall off the top of my head the varying specific ways they measured it, but that's something that you would also find in our paper.
Thank you very much for the answer. I see that Ines, you have raised your hand, so please go ahead.
Yes, hi, thank you for the very nice talk. My work is giving support to researchers, and one of my missions is to incentivize them to publish in open access. The problem is that in the other side, I always have the question, but why should we do that? And I think you gave some tips, but I would like to hear from you. What should I say to them when they say to me, why should we do that, regarding the specific problem of the impact? Because the other talk, they are used to it because they have more the open visibility, etc., etc. But for them, the most important thing is the impact, the citations, and the things that matter for the academic CV. So what advice do you give to me to transmit to them? Thank you.
I can try to answer that. So I think although the evidence is a little conflicting, in general, we do find that publishing open access and also only just publishing, for example, green open access leads to more citations. And the tricky part, kind of one of the most important confounding factors in this field is the publication venue. Of course, if you compare a relatively new open access journal with established closed journals, then you'll see lower citations in the new journal. But of course, that's because there's no community around this new journal yet, let's say. But even if you look at green OA, we find relatively consistently that the studies that looked at that report higher citations. So that would be kind of there's a first argument that alludes to this fact that researchers obviously are looking at citation impact and what they can do there. And I think this other aspect that I mentioned, because science is there and research is there to kind of not only benefit yourself, but others as well. And so first of all, that research is available to other people simply by without a barrier to access would be, I think, but of course it's tricky, but would be one beneficial point. And the other aspect that we unearthed is it comes from one study, is about the diversity of citations in terms of geography, and I find that quite an important and profound point. That the evidence suggests that if articles are published open access, then people from more countries around the world are able to read it and cite it. And so therefore, the impact that you have as a researcher is less confined to a very narrow set of other researchers, but more people around the globe will be able to benefit from what you're doing.
Thank you, Thomas, for replying for this question. I hope it answers Ines' question. And I see in the chat that there is a question about the economic impact of the open science. So I just want to clarify that we will have in our upcoming sessions, we will focus especially on the economic impact of open science, and also we will explore more about cost-benefit analysis framework for open science. So you can check those sessions and you will learn more about the economic impact of open science. And I want to again give you the floor to ask any other questions. And before you will think about your question, so I have one question for Petros. Petros, in your analysis of open access impacts on research visibility and collaboration, how significant are the differences between different types of open access models like green, gold, diamond, and so on? And which of these models do you think that has the most potential for fostering interdisciplinary collaboration in these fields that you study? Oh, you are muted.
Yeah, sorry for that. So I said thank you, Teresa, for this question. So actually, in general, our analysis showed that open access, increased research visibility and collaboration across the fields, right? And when we focused on the academic impact indicators, apart from all the rest, let's focus on the academic impact indicators. For example, we've seen that, for example, open access publications that also had a mix of open access colors, so they also had gold and diamond, and not only green, actually received more citations and more influential citations rather than only relying on self-archiving. So in that matter, even though all open access models may improve access, this indicated that if we focus on gold and diamond open access, this seems to give a boost to these metrics, to the visibility and engagement, although it might have some negative effects as well in the field citation impact, as we've seen. So, but in general, our evidence showed that gold and diamond open access seems to support collaboration the most, and to provide immediate and free availability of research, which actually makes it easier for experts, for example, for different fields to work together and collaborate and get also citations in the community.
Perfect. Thank you very much for your answer. And there is another question in the chat. So would it make sense in your study to distinguish between diamond open access and other forms of open access publication? Because it seems to Sandra that the models, even if they lead to open access, are somewhat different in terms of who can pay APCs.
Mm-hmm. Thank you for that question. Actually, we have considered also splitting into not only comparing green versus the rest, but also having a more in-depth analysis of, for example, green versus gold versus diamond, so on. What we found out is that in our collection, the diamond publications were actually not that, we do not have that many in our collection. So this actually limited our analysis to only, for example, focusing on getting a mix of all this together. But it is something that we considered. And also we have considered into splitting for hybrid open access, so a mix of open access and paywall content, and bronze, which actually publishers make free the publications temporarily, and then they close them again. So this is something that we have considered, but due to limitations of our data, we could not measure. But if we expand, for example, our collection size, then maybe this will be possible as well. However, even that is a little difficult to do, because when you come towards the current year, the number of citations and citation impact is not so stable, because it needs publications that are actually published, for example, in 2023, it makes sense that they will not have yet gathered the amount of citations and influential citations from those that were published, for example, in 2018 or 2019. They did not have the time frame to gather those citations.
Perfect, Petros. Thank you very much for the answer. And there is actually a follow-up answer. I don't know if you would like to take it, or if Petros or sort of a comment that Irat would like to argue that bronze does not meet the Budapest definition of open access. So then there is basically a question if it should be included or not.
Sorry, can you repeat that, Teresa?
Oh, that bronze does not meet the Budapest definition of open access.
Yeah, exactly.
So yeah.
Yeah, so that's why we did not we considered it, but we did not include it in our analysis. We focused mainly on gold and diamond, but these are all considerations that actually we were having when we were designing this case study to see the effects of each color separately. But yes, I agree on that. I agree on Irak's.
Perfect. Thank you very much. So I have another question for Thomas. In your scoping review, you mentioned that there is issue of equity and diversity being negatively impacted by open science practices. Can you elaborate on some of these unintended consequences that you observe in your scoping review, and what strategies you might use to mitigate these challenges?
Yes, thanks, Teresa. So one of the, I would say, at least to me, most well-known aspects in that area is related to open access publishing and this article processing charge model that tends to create a barrier for who can publish in which journals, which is, of course, a problem. So there is the existing barrier that in terms of who can publish in these journals is determined by certain cultures and norms, and there can be a general exclusionary force here for people from the global south, for example, because ways of doing research might differ. And to that comes then this barrier that people would have to pay very large fees that are just not affordable to many researchers. And to counter that, I would argue we would need to foster models of open access that don't have such forces, such fees, and that would be clearly pushing more for diamond open access, for example, but also recognizing that opening up your research via green OA is completely fine and also enables others to read your research, so to at least deposit your papers whenever possible. And the second aspect just mirrors what I closed in terms of the recommendations, that we, for that to happen, also need to reshape our cultures to a certain extent, the culture around research assessment, that we can focus more on the diversity of outputs and diversity of certain open practices, and reducing the weight of publishing in very high impact journals, and therefore focusing more on the actual quality of the research and less on where it's published.
I couldn't agree more. Thank you for your answer. And I think that we can now close up. So I would like to ask Petros to you first. What would be the key takeaways from this webinar for the participants to take home? What do you think?
I mean, I'm not muted, right? Perfect. Actually, the key takeaways in terms of the case study that we did is that monitoring whether open access and the different colors of open access helps academic impact is much more difficult to do than in theory, and we witnessed that through our case study, because there are many things to consider. There are many confounding factors, and for example, you think that you found out, for example, that gold and diamond open access is better than only green, but then you have to control for the excellence and the mandates that are in place. Also, it might be field specific, and there are many things to consider. So it's much more difficult to do than in theory. But all our results and everything that we have tried so far seems to all point out that indeed, yes, taking in consideration open access models such as gold and diamond indeed helps in collaboration and visibility, and in the development of new emerging topics and the persistence of those topics over time.
Perfect, thank you. And the same question for Thomas. One key takeaway for our participants, what it would be?
Thanks, Teresa. Just very briefly, I would summarize the inputs that I gave with that open science has demonstrable benefits overall if you take the broad picture, but we need to be mindful of areas where there are negative consequences. And we also need to be mindful of when we encounter claims about the impact of open science, whether they're actually related to the impact or whether they're logical deductions from the uptake. So really to look for specific instances of people analyzing the impact specifically and not just the uptake.
Perfect, thank you, Thomas. Can you please switch the slides, Petros?
Yes.
Just before we conclude, I would like to invite you for our upcoming training sessions, because there is much more from PathOS to come. So I would like to encourage you to register for these upcoming sessions. And with this, I thank you very much for participating. We are very appreciating your time and your engagement today. And please, if you can take a moment to share your feedback with us, because it's essential for us to improve our future sessions. So if you can, please scan the QR code on the screen that you can see, or you can also use this link that I'm just sharing with you in the chat. So one more time, thank you very much. Thank you, Thomas and Petros, for your insights, and thank you all participants for joining us for our PathOS session. So thank you very much and have a good day.